second entry for today is Edge Impulse, with a groundbreaking algorithm that brings real-time object detection, tracking, and counting to microcontrollers, so even down to microcontrollers. So the aim of this work is to find the right trade-off between cost, computational power, and the size of machine learning models. So this is a potential enabler for embedded applications on edge devices. Tell us more, Mikhailo. Mikhailo, are you there?
Müssten Sie es sehen, oder? Sehen Sie die Präsentation?
Ich sehe die Präsentation, jetzt nur noch in Vollbild gehen und dann hätten wir es auch schon.
Ich höre den Kollegen nicht sprechen, nur zur Info.
He's coming. There he is. Hooray! Welcome.
Hello, this is Mihailo speaking. I'm dialing in remotely. Unfortunately, I couldn't attend in person. But nevertheless, I wanted to take the opportunity to thank the organizers for this interesting Runners Up Award. I'm the head of sales for EMEA in Edge Impulse, and I want to talk to you about how we can get essentially vision models onto microcontrollers. So FOMO stands for faster objects and more objects, and essentially is enabling real-time object detection on microcontrollers. Let me get to the next slide. So who and what is Edge Impulse? I'm going to touch that a bit. Then what is our innovation and why does it matter? Who and what is Edge Impulse? We have three answers to that. One is we make smart machines, which means we make machines who have microcontrollers, microprocessors, sort of self-aware with ancillary sensors. How do we do that? Well, we do that with custom machine learning. And custom machine learning is very difficult to depict for a custom motorbike. All of that, what we do, actually runs on embedded systems in some sort or shape, which means we are not dependent on any cloud to do that. So in a nutshell, we provide this really fantastic platform, very easy to use, for people who are in the embedded space and have little to no machine learning or data science expertise. And as a end result, you get a C++ file you can deploy anywhere on the edge or in embedded systems. With behind because we have more than 50,000 developers on the platform and many projects. Amongst our customers, you can see here below, are we're very proud about NASA, but also Vision Innovations with us. This is a little bit more about growth in the past, but I don't want to bore you. I want to just here to actual innovation. So there's a difference between an image classification and an object detection, as you can see. The interesting part is that when you look from a hardware standpoint, this requires quite some substantial compute power when you just look at a face and understanding if there is a versus knowing where is the face. So we thought we need to kind of rethink that. And what we've managed to do is, let me see if I can start. This should be, So what we've done is essentially, and what you see here is of a which is a very small microcontroller, which does a Centroid-based object detection, extremely slim, small, and can run on those. So let's see. The next part, which is really an interesting one, is that we are having not only faster objects and more objects on microcontrollers, but we also can use that to do an anomaly detection with an extremely small memory footprint of 200 kilobytes with 30 frames per second on a Cortex M7. And the really part is every single cell here becomes kind of an anomaly detector And let me show you what we can achieve with 100 video trained on the ground. See down here, whenever something new comes into the image, it's immediately recognized as an anomaly with extremely small data amounts. That's what's possible these days, which is really impressive. So, why does it matter? Well, you can see it here. The frame, all these really micro, astonishing, and even 4, which is a below, I don't know, $1 price, we can still do 5 frames per second as a reference point. That in mind, we would like to invite you to speak to us if you have any cases think microcontrollers can help you to solve your vision problems with this new, very unique technique. Thank you.